So yeah, I'm going to talk a little bit about embedded Swift. And first, I'll start with a few words about myself. I'm a freelance developer, mostly specialized in low-level and real-time software on Apple platforms, mostly macOS and iOS. And I'm always interested in exploring new technologies and frameworks, and that's how I started to play with embedded Swift about 1 year ago. And so with embedded Swift, it's possible to develop Swift applications for microcontrollers. For example, this Pong game is written in Swift. It runs on an ESP32C6 microcontroller, and it uses the microcontroller's I/O to get inputs and drive the display. And the code is not based on any operating system. It runs directly on the processor. And so this is what the project looks like. So if we look at the main function, we have initialization, and then basically what all we have is an event loop that receives events from the rotary controllers and the buttons, and that handles the game state and drives the display. So that's Swift basically. And more about this later. Uh, what is embedded Swift exactly? First, it's a subset of the Swift language. So that means that embedded Swift code is also valid Swift code that can be used in other Swift projects on other platforms. It's implemented as a special compilation mode, and the compiler still produces .o files that can be linked with other .o files, including those produced by C and C++ code. That means that embedded Swift can be integrated very easily with existing embedded projects. And also it's easy to include C libraries into an embedded Swift project. There is almost no runtime. There's even a mode where only static memory allocations are allowed. So that's for very tiny microcontrollers. And there are a few limitations because of that. There are a few limitations compared to regular Swift. I'm going to discuss that later. And lastly, it's still a work in progress. It requires a development version of the Swift toolchain, and you need a dash enable experimental feature embedded compilation flag to generate your code. So embedded Swift supports many instruction sets, including ARM32 and ARM64. That's not a surprise. And also RISC-V and STM32 microcontrollers. For example, the ESP32C6 I'm using is a 32-bit RISC-V microcontroller. Few words about the tooling. The main tool, of course, is the compiler itself. It's part of the Swift toolchain, and currently it requires to download a nightly build. So on swift.org, you can download the nightly build of the toolchain. And embedded Swift does not come with an operating system. Instead, each manufacturer provides some tools to use the features of their microcontrollers. So these tools can include different things. At the minimum, you have definition files, mostly to be able to use the I/O. Usually they are provided in C, and it can be either .h files with pound defense constants or C functions that you can call to use the hardware. And usually you have some kind of toolbox for basic operations, such as thread management, messaging, and so on. Sometimes you'll have a build system to make it easier to generate the executable binary. And then you have a way to upload the binary to the chip. So all this is usually provided by the chip manufacturer. In the case of the ESP32, the manufacturer is expressive, and the definition files they provide are quite extensive with high-level functions for everything, including radio connection, so Bluetooth and Wi-Fi and so on. The toolbox is based on FreeRTOS. It's an open source framework that provides things like threads, queues, messaging, and so on. The build system is based on CMake and Ninja with a Python script to trigger everything. And the upload connection is JTAG connection provided by the USB port on the ESP32. And Expressive provides a Python script to make the upload easier. I didn't mention an IDE because it's not part of the tools provided by the manufacturer. Basically, you can use your own IDE. It can be just a simple text editor, such as BBEdit, and the command line to build and run, or a full IDE. Probably Xcode is not the best IDE for embedded Swift, at least right now. And for myself, I use VS Code, and yeah, it works nicely. There are a few plugins that help. So now we can talk about the limitations. Some limitations are by design because of executable footprint or memory consumption or performance. Some limitations are optional. You can choose to enable or disable some features, such as, for instance, dynamic memory allocation. As I said earlier, embedded Swift is still a work in progress. That means that some other limitations I'm going to mention are temporary because the features are not implemented yet. And lastly, some limitations are under discussion. For example, Codable may or may not be available in a future release. So, what is probably the most visible limitation is that embedded Swift does not support introspection or existential types. This is by design because embedded Swift has almost no runtime. For introspections, that means mirror is not supported. It's not frequently used anyway, but it also means that some string interpolations won't work as expected. So you have to deal with conversions and so on. Yes, I was talking about existential types. So the limitation about existential types mean that you cannot use the any keyword except in some rare cases. For example, if you define a protocol, you cannot have an array of elements conforming to that protocol unless the protocol inherits from any object. This has some consequences about the way you organize your code. For instance, if you define a throwing function, you cannot declare it just as throws because throws is a shortcut for throws any error. so you need to use typed throws everywhere. And besides that, it is still possible to use generics provided everything is known at compile time. Um, Another limitation, but this one is temporary. As for now, there is no support for concurrency. That means no async await, no actors, and so on. This is only temporary, and it's on the roadmap. So it can be implemented at different times for each chip because it requires support from the chip manufacturers. And lastly, some limitations are optional. For example, embedded Swift does not include libunicode data tables by default, and this choice was made to reduce the storage footprint because it's a huge library. It's a few megabytes, and it's huge for microcontroller. And that's well, the consequence of this is that some of the string operations are not supported, typically the ones relying on grapheme clusters. So for example, string.count does not compile. It's not possible to use a string as a dictionary key because strings are not equatable. So there are two ways around this. Either you can build with libunicode data table, and then you add 2 or 3 megabytes to your generated code. So it can be too large to fit on the chip. The other way is to use Unicode scalar values instead of strings. So you use the string.utf8.count syntax and so on. And so the behavior will not be exactly the same as with strings. For instance, you can have the same string that can be encoded in 2 or 3 different ways. But in most cases, that's not an issue. So there's WWDC around the corner, and I think some announcements regarding embedded Swift are very likely. First, with the recent introduction of Swift package traits, maybe we can use SPM, or Swift Package Manager, as a build system. Then probably we'll have some news about concurrency. And hopefully embedded Swift will be included in the official toolchain so that we don't require a nightly build to use it. And if not, if it's not the case, there's a new Swiftly command line tool that can make it easier to use the nightly builds. I haven't tried it yet, but so currently I'm using a script to force the latest toolchain when I'm using embedded Swift, but it's a possibility. And that's about it. If you are interested in embedded Swift, there are a few resources, mostly at Apple, and including some code examples for different microcontrollers on GitHub. So that's it. Thank you very much.